Welcome everybody. Good morning to this information session on responsible electronics, which is a Pathfinder challenge of the work program of the European Innovation Council 2023. We are organizing this session so that you have the opportunity to ask all your questions that you have around this challenge to the program manager, Isabel Obieta. Isabel, I cannot see the slides. Could you go to the agenda? I now see just the screen of Jenny. Isabel, I think you need to share again your presentation. Yes, very good. And now in presentation mode. Yes, so today is the information day on responsible electronics, and you can ask questions to the program manager about anything which is still you would like to know more about this topic. And you can do that through Slido, sly.do, and then you should use the code challenges. I also want to remind you that this meeting is recorded, so if you want to stay anonymous, then please don't put your name into the Slido. So this is very important because today is your possibility to ask questions. So if I now go to the agenda, I will start with a short introduction of the European Innovation Council and what its objectives are. And after that, then Isabel will tell everything about the Responsible Electronics Pathfinder Challenge. When she's ready, then we will go over all the questions that you have asked. And after that, there are 5 organizations interested in submitting proposals to this Pathfinder topic, and they have the possibility to present in 3 minutes, let's say, their knowledge and experience and relevant background that they have. So that's for possible matchmaking between participants for future proposals. And then around 11:30, we expect to end this session. So if we go to the next slide, then yes, the European Innovation Council, it's part of Horizon Europe, and it's located in Pillar 3 of Horizon Europe, which is called Innovative Europe. You see it's there on the right-hand side. And it is together, for instance, with the European Institute of Innovation and Technology, the EIT. And that's to also, to explain the special nature of the European Innovation Council, and that is to bring the good research that Europe is doing to the market as soon as possible. So in this slide, you also see, for instance, Pillar 2, Global Challenges and European Industrial Competitiveness. And that is also where a lot of industrial applied research is happening, also in the area of electronics. Key digital technologies, the joint undertaking is, for instance, part of Pillar 2. And also there's Cluster 4 on industry, digital industry and space, which is also very relevant for the electronics research area. So the European Innovation Council, the total size is around 10% of the whole of Horizon Europe. So the budget for 2021 to 2027 is 10 billion euro, which is of course a very large amount of money. The the European Innovation Council has 3 different instruments. The first one is Pathfinder, which is dedicated to research, to low technology readiness level research, so early ideas for which proof of concepts need to be developed. This is for consortia, and today now we will explain you the Pathfinder Challenge on Responsible Electronics. So your today will be on innovative, groundbreaking, potential ideas for new responsible electronics, but it's still very risky. You have ideas with a lot of potential, but it's not proven yet that this will really work. So more research is needed in this area. So if after the end of the project you have validated your ideas, you have developed prototypes or proof of concepts, it could be that this is ready for the market, but it can also be that it still needs a bit of further maturation and development of business models, for instance. And for that, we have the instrument which is called transition. And in transition, the idea is that you would move up the technology readiness level of your technology from 4 to 6, so that at the end it would be ready for the market. And then our third instrument, it is accelerator, and there that is for dedicated to SMEs or to startups that already have a product and a business model and that now need to scale up their innovations. So Pathfinder and Transition, they both work on with the concept of grants, and whereas the accelerator, there will be a grant part, but also an equity part. And in the accelerator, the financial size can go up to 15 million euro, because it's that amount of money which is needed to really scale up the innovations. So if you go to the next slide. On this slide, you can see again the 3 instruments that we have, Pathfinder, Transition, and Accelerator. And I already explained that with each of these, the technology readiness level goes up, but at the same time, also the business readiness level goes up. Whereas in Pathfinder, it's still research, and your main question could be, what can this technology do? How can I make this technology work, that it really does what I want it to do? And there's not yet a lot of considerations about possible customers, even though there should be some, of course. In Transition, this business readiness level is already starting to develop further, and in Accelerator, it should really be there. And in Accelerator, the companies doing that, they should answer the question, why? Why are companies wanting to buy my product? What are the user needs that my product is solving? So you can see that also here we move from a question what around technology to the business question, where it's more why are customers interested in my technology. We go to the next slide. To the next one, please, Isabel. So the EIC really wants to accompany organizations on their entrepreneurial journey and going from research to the market, and we give financial instruments, but we also give proactive management. And that is also something which is unique for the European Innovation Council. In other parts of Horizon Europe, we might do that a bit, but here we do it really very systematically. And the type of services that the beneficiaries will get are, first of all, business acceleration services. So this is available for all projects that have an EIC grant or equity. And through it, they can get access to to entrepreneurs. For instance, we organize dedicated events with groups of investors who are interested in projects that the EIC is funding. You can get access to mentors, people who help you on your entrepreneurial journey. And also access to ecosystems. For instance, what we organize are corporate days where certain corporate would like to meet also the startups that we have in their domain. And then there would be a day dedicated to building relationships between this corporate and the possible startups, in the hope, of course, that this will become sustainable relationship for the future. So there are many business acceleration services, but what we also have, which is unique, are the program managers. So we have 10 program managers in the EIC. And on the right-hand side of the slide, you can see the specializations of the different program managers that we have. And they are experts which are hired for 4 years by the European Commission and as a program manager. They have a background both in research, but also in bringing the research to the market. So they have a very special profile. And their task is to, first of all, to define areas where Europe should invest more, because we already have a lot of potential, for instance, in the form of good basic research. But we're not yet bringing that enough to the market. So the vision that the program managers have, they lead to the challenges in the work program that we have. And that's the top-down part of the European Innovation Council. And then once projects are selected as part of this of these challenges, then the program manager works with all these projects to, for instance, overcome common barriers which are there among all the projects, to really build relationships between all the projects, so that once these are really becoming companies, you can still work with each other and, for instance, become partners in a supply chain or other elements. So the program manager brings portfolios of projects further. So if we go to the next slide, then this slide gives an overview of the whole work program of the European Innovation Council of 2023. So the total amount of funding that is available is 1.6 billion euro. You can see that we have the three instruments that I said: Pathfinder, Transition, and Accelerator. And Accelerator is by far the largest instrument that we have. And each of the instruments, they have an open part where you can submit any topic that you want, as long, for instance, for Pathfinder, it is this potential groundbreaking research. And it has a challenges part. So that's the same for each of the three instruments. And if we go to the right-hand side of the slide, there you can see all the challenges that we have. And now we are discussing the responsible electronics Pathfinder topic. At 11:30, we will have an information session about the chip scale optical frequency combs. That's also with Isabel Obieta. And we have also this afternoon at 2 o'clock, which might also be interesting for you, our accelerator challenge on semiconductor chip design. And that will be done by our other program manager, Samira Nick. So if we go to the next slide. On this slide, you have an overview of all the deadlines of these calls. That's of course also always important to know. And for Pathfinder open topics, the deadline is already quite soon, on the 7th of March. But for the challenge topic, there's still some time. The deadline is 18th of October, 2023. So yes, so everything around let's say, the legal base for this whole call is described in the EIC Work Program 2023, where you can see here a reference to it. And today we really want to focus on the specifics of responsible electronics. If you have questions, other questions which are of a more general nature about how to apply, or you want to know something about accelerator in general, then we recommend you to look at the previous info day that was organized on the 13th of December, and where you can see here a link to the recording of that. So with that, I want to give the word to Isabel Obieta, our program manager on responsible electronics.
So can you hear me?
Yes.
And see me? No?
No, you have to put your camera.
Okay, now I think I'm done, no?
Yes.
Is that right? Okay. Yeah, good morning, everybody. Glad to be here. Really welcome you. And I really appreciate those of you that are interested in this topic. So yeah, as this slide is mentioned, the goal of the day is this info session is to provide some background to the challenge, explain the challenge as is presented in the work program, answer to your questions, and it's not really to provide you feedback of the appropriateness of your individual proposal to this challenge call. For that, I think you can go to your NCPs, to your national contact points. So yeah, again, just to repeat, the legal basis is the EIC Work Program 2023 that you have available on our website. So going directly to the Pathfinder, responsible electronic, as already Anne-Marie told you, we will have, after my presentation, the Q&A session, and then we will dedicate some time to 5 proposers that want to pitch their ideas to find consortiums or new collaborations. So as explained before, there are open calls and challenge calls. The target of the challenge calls is to support coherent portfolios of projects with predefined thematic areas with the aim to achieve specific objectives. And this is the case for this responsible electronic challenge. There are some differences in the challenge calls with reference to the open calls, as you can see on this slide. So one of them is like the indicative budget, which is slightly higher in this case. It can go up to 4 million euros. Another important is the deadline that already Anne-Marie told you. So it's October. Still, we have time to prepare this instead of March. And then the proposal, it's also in its part B, it's a little bit longer. You can go up to 25 pages instead of 17. And finally, also the consortia can be different. In the case of the challenge calls, you can have single entities can apply to the topic, to the call. So, but for the sake of time, I will not enter into details, and I recommend that you check the eligibility criteria under the work program. And so coming directly into the what responsible electronic call is about, first of all, I would like to give some background to the challenge, specifically referring to the CHIPS Act. I'm sure that by now you have all heard about it. So yeah, from the CHIPS Act, you can see that the market forecasted for semiconductors in the next 5 years increases for all device categories. Of course, this implies enormous increases in terms of energy, water consumption, as well as in the use of critical raw materials or hazardous chemicals. If we now check the supply chain distribution used also in the CHIPS Act, we can see that Europe is not always sufficiently present in all the blocks. So the percentages of the market share of the EU for some of the blocks are really low, showing certain deficiencies in our semiconductor supply chain. So we at the EIC are addressing innovation for several of those blocks. A challenge around chip design for accelerator will be described this afternoon by Samira, as Anne-Marie already told you. But here we're going to really to go and talk about low TRL Pathfinder project, and we are going to tackle mainly materials and manufacturing aspects. And indeed, with the emphasis in sustainability, so we are really looking for breakthrough ideas that can be real game changers in terms of environmental impact. When introducing sustainability arguments and targeting objectives like eradicating and reducing carbon footprint for semiconductor, Analysis can be done looking at design aspects, at manufacturing, or at its use, repair, reuse, and recycling aspects. So anyhow, this Pathfinder challenge focuses mainly on new materials and new ways of manufacturing. So in relation to the use of materials, shifting from fossil-based materials to bio-based and decreasing the use of less abundant ones could be an important game changer here. In relation to manufacturing processes, the changes can come, for example, from introducing material and energy efficient additive processes, or from others like reducing the energy or water consumption and avoiding the use of certain chemicals. Of course, also by designing and developing radically new devices, maybe inspired by how nature interacts with the environment, is an important topic also. And finally, another important game changer could come from the design, for example, in the interconnections of the devices for easy recyclability or for reuse, for example. So with all this, everything is in line with the EU Circular Economy Action Plan that really fosters towards a circular economy with effective waste and carbon recycling strategies. From the critical raw materials resilience document that I provide the link here, you can see that many of those materials apply to electronics, indium, germanium, and many others. So it's extremely important to find radical innovation for all those devices. Another framework of interest for the topic is the one dedicated to safe and sustainable by design chemicals and materials that I suggest that you really go through it. So in the next slide show how the call reads. I'm not going to read everything, but some of the paragraphs that I think are important, I will go through them. So responsible electronics represent a unique opportunity for the future of EU autonomy in a decarbonized and digital society. Besides reducing the environmental impact of the electronic sector, innovations can help also can help Europe to overcome the current chip crisis by reducing the dependency on critical raw materials and traditional high energy demanding semiconductor processes. So moreover, investing in responsible electronics would be beneficial for the entire semiconductor ecosystem in Europe and will uphold the EU technology sovereignty. And that's what the call is about. So with all this in mind, the overall goal of this challenge is to create opportunities for the discovery of new environmentally friendly electronic materials, reducing its environmental impact and the need for critical raw materials and hazardous chemicals. I will repeat this kind of sentences many times, but it's very important that this is really the overall goal of this challenge. So projects supported under this challenge are expected to offer either materials with improved properties, such as flexibility, durability, and others, materials processed with low energy consumption and low carbon footprint processing. You all know what I'm talking about, maybe additive process again, or also alternatives to replace common electronic materials, such as silicon or silicon nitride, for example. So the specific objectives of this challenge are to support the scientific community in reaching, again, breakthrough in the discovery of advanced electronic materials for unconventional devices. I will not go through the details, as you can read them on the call. A non-exhaustive list of processes and devices is also available on the call that I will skip today. Anyhow, I would like to highlight that the life cycle thinking approach should be considered at all times. And this is important. Huh? And finally, for the expected outcomes and impacts, I will repeat myself again. So this challenge is expected to contribute to the development of materials with new properties or replacing materials used in current electronic devices with materials which reduce dependency on critical raw materials, are sustainable, having a low environmental footprint and developed recurring to the life cycle thinking approach. Let me highlight that it is expected that the challenge will lead to the development of lab-scale validated proof of concept devices based on the developed innovative materials and manufacturing process. This is also very important. So you really need to finally validate it in a proof of concept device. So Going to the specific conditions mentioned in the call, I would also like to highlight a couple of things. One of them is that we are looking for projects with multidisciplinary and cross-sectorial approach, and that all projects are expected to conduct a full life cycle analysis of the proposed solutions, and they shall apply or identify a methodology to measure the environmental and the carbon footprint of the proof of principle that will be developed during the project. I think it's also important to mention that the packaging and durability should also be taken into consideration. I know I'm repeating myself a little bit with all these aspects on reduction of the use of raw materials, full life cycle analysis. So it's breakthrough, but also we need to really identify a methodology to measure the advantages of what we're proposing in terms of materials and processes. So finally, I will go through the portfolio considerations, and I would like to let you know a little bit how the evaluation journey will happen in the case of the challenge. So on this slide, the procedure for the evaluation is shown, and you can see that the portfolio considerations come now into play in a second step, in step 2, after the, let's say, the normal assessment of each proposal, which is done separately in step 1. So step 1 criteria is basically the same both for challenge and for open calls, except that under excellence, experts will analyze how relevant are the objectives of your proposal in contributing to the overall goal and to the specific objectives of the challenge. So yeah, as well as on the open one, but very specific to what is written. So I recommend that you really read through the challenge very carefully. And also under impact, they will have to assess, the experts will have to assess how credible are the pathways to achieve the expected outcomes and impacts of the challenge. Again, go read them carefully. So in step 2, this is the main difference here that I want to really detail and make you understand. So the evaluation committee will aim to compose a balanced and diverse portfolio. So first thing we do is proposals will be mapped in the selected categories that I will show in the next slides. And then starting from the highest rank proposal, a portfolio of proposals will be selected based on shared components, while ensuring diversity among the selected proposals and coverage of the, in this case, 5 categories that I will show afterwards. So this implies that if the evaluation committee considers that a highly ranked proposal does not have complementarity with the other proposal, it might not be selected for the portfolio. And also, in order to ensure diversifications, proposals which the evaluation committee considers to be very similar to a proposal already included in the portfolio, it might also not be selected. So consequently, this means that the project selected for funding after the second step might differ from the ranking list established for the first step. Okay. So this, I think it's very important. And it doesn't want to change now. To the next slide. Let's go. Yeah. So for this step 2, we have published a challenge guide, including the portfolio considerations that you can go through in this link. Today, I will explain those in detail and give some examples. So the following categories have been selected. It might be the case that a certain proposal falls into 2 categories, which might enlarge the opportunities of finding shared components. So in any case, it might benefit your proposal. So this will be assessed by the evaluation committee. Let me give some examples of each category. So for example, for the organic small molecule and or polymeric materials, of course, graphene, derivatives of graphene, graphidine, hexene, and other forms of carbon, they could fall here. Also, metal-free conjugated polymers, for example, synthetic organic semiconductors from sustainable feedstocks, and also everything related to biopolymers, saccharide, protein-based materials could be another example that fall into this category. So everything related to organic polymeric materials. For the second category, for example, the transition metal halides that generally involve non-toxic and earth-abundant elements, suitable for low-cost, low-temperature synthesis, could be of interest. Also, the use of more common semiconductors like molybdenum disulfide from from green solvents, like using ionic liquids, for example. Also, amorphous metal oxide semiconductors, of course, without indium, and processed at low temperature and without vacuum, could fall into this category. Those are just examples I'm giving. It doesn't mean that other things cannot come into those categories, but I'm just giving examples so that you understand what we are looking for. For the hybrid organic inorganic materials and or nanocomposites, conjugated polymers or novel nanocompounds, of course, not using critical raw materials, could be of interest. And for the fourth category, the vision could also be to mimic nature for creating a novel class of engineered materials able to deliver complex functions. Nature is an extremely efficient energy consumption engine that we could use for infinite inspiration. And finally, in the others, not falling in the previous categories, radically new materials of processes in electronic devices, particularly those suitable for functional inks, passivation, encapsulation, packaging, and or flexible, stretchable substrates. Of course, I guess this is the easy one. Examples could be the use of chitosan as a substrate, novel inks made of specific nanowires with certain effects in the quantum regime. There are many examples that fall. But again, let me tell you that those are examples, and we need breakthrough ideas. We don't want things that are already close to the market or are. So you really need to be at low TRL and think about game changers. So once we have categorized the different proposal in those 5 categories that I just explained, then once this has been done, we will look for synergies or what we call shared components. And this can happen either at device level, or it can also happen at what we call technological approach. So mainly any device can be tackled, you can see on this list. But again, we do not want to have all proposals dealing, for example, with biosensors. So we will look for diversification at device level if the same category of materials is proposed. And this same occurs for the technological approach. So of course, all additive processes are welcome, but we do not want to have all the projects dealing with inject, for example. So the use of vapor or other energy efficient sources could also be welcome. And we need to diversify while at the same time we find commonalities in all your projects. And this is how we're going to try to build the portfolio of projects. And let me give you some examples also that maybe can also help you in understanding what we are doing. So there are a number of EIC running projects that deal with graphene, with biomaterials, or with novel processes that are somehow addressing some of the objectives of this challenge already. So some of the examples of running Pathfinder projects deal with hybrid organic inorganic materials and nanocomposites, like some of the acronyms are PulseCom, Symphonias, COLED, MITIX. Others lead with nature-inspired solutions like DNA Ferrylite, Coronet, 3D Bricks, Bayflex, which are from the last call last year. I have selected a couple of examples from our Pathfinder portfolio to illustrate this point. So the first one is called Pringle, and it deals with proteins, protein fibers. It's a project tackling the possibilities of those protein fibers for the next generation of electronics. It's very open in terms of devices, talking a lot about sensing, but it's quite open in terms of devices. Another interesting project also that could also jump into this portfolio of projects is Progeny. It's leading with proton-based devices that target a radical and sustainable breakthrough in device and sensor innovation using soap films. Both could fall in both in the category 1 and category 4. They are trying to somehow mimic nature also. But there are many other examples in the literature. I don't want you to stick to those, like emission electronics or the use of phospholipid membranes could also be extremely interesting. There are so many examples that are already people working on those. So really breakthrough novel ideas. And those are the ones that we want to see. So other examples picked up from the literature, but again, many can be relevant to the topic. So I selected 3 very recent articles. So one of them deals with solution processable inorganic zinc oxide nanowires. With this could be category 2, of course, and the target in this case is a degradable high-performance photodetector. And the whole paper deals a lot with green technologies. But there are also studies on, let's say, colloidal cadmium-free quantum dots using greener solvents for their synthesis. There are many things running around that. An example for category 3 could be this hybrid, for this hybrid organic inorganic and nanocompounds. I selected one on, for example, silver nanowires in PDMS for strain sensors. And also, for example, another example for category 5 are the use of photocurable metal chalcogenide inks, or maybe the soft hydrogel electronics, where they fabricate also strain sensors based on these materials. There are, again, many examples also on novel elastomers that could be used as a substrate. And in this challenge, we want to go a little bit farther by also performing the life cycle analysis and really analyzing the benefits of your solutions in meeting the specific objectives of the goal. So it's not just about thinking in radical innovation. You have to think about the device you want to achieve, and you have to do some calculations in terms of your life cycle analysis and reduction of the carbon footprint. So it's not just you put your novel bio stuff there. You need to go for a device, and you need to check that the numbers in terms of carbon footprint are there. Okay. So with this, I'm really coming to the end of my presentation. So as a wrap-up slide, I wanted to reiterate what we aim at is enhancing the opportunities of the materials developed by the different projects, ensuring that a higher number of relevant application devices are available. So this is why we build this portfolio of projects. And we also aim at enhancing the commercialization potential of the portfolio of individual projects by ensuring your access to all of them. So a common strategy plan or a roadmap for the challenge will integrate the activities and milestones of the individual projects into a shared set of specific objectives and activities across and beyond the project. In particular, the challenge roadmap strategy plan will include activities on the transition to innovation and commercialization and to stimulate business opportunities. I'm not going to go to this non-exhaustive list of activities, but those require the active participation of the portfolio members to a series of meetings. And with that, I want to highlight my last sentence there, the recommendation to add a dedicated work package for portfolio activities with at least 10 person months for those activities, which we understand are extremely interesting and important to get the best out of this portfolio of projects. And with this, I am done. Thank you very much for your attention. As mentioned before, now we have the Q&A session. So I hope you have already started putting your questions on the Slido. So I will be together with my colleague on Pathfinder unit, Dalibor Krek, that will help me with some of the questions related to the general ideas of the Pathfinder calls. So thank you very much again. Juliana, the floor is yours, or Jenny. Thank you very much.
You go ahead and read.
I go ahead. So yes, I'll start reading the first one. What is the status of British laboratories? Is it possible to include them as partners, and how so? So this is for you, Dalibor.
Well, the UK can always be a partner, but depending on the current association to the Horizon Europe, it's either counted as an associated country or as a third party. Currently, the status, I'm just looking at the page. I will send you the link for a page with a list of all third countries and associated countries. It is expected that the UK will sign an agreement to associate to the Horizon Europe. Since the call deadline is on the 18th October, we expect that at that time the UK will be a full associated country and will be counted as a member or associated country. If not, then it will probably be counted as a third party or a third country, which still means that it can be a partner, but it's not counted as one for the legibility. I hope that answers your question. As I said, the situation is changing with time, and it depends depends on the status of negotiations when the call deadline is due, and that is in October.
Thanks, Dalibor. I think the next one is also for you. So what's the success rate of the challenge call? Are single applications less successful than consortium?
For the
There are two
first
questions
one,
in one.
success rate, you can count between 10%, 15, 20 at most. So it's well, it's some would call it low, some would call it high. It depends. It's higher than the success rate in the open call. That's for sure. When it's lower than 10%. And it depends on the challenge you are applying to. And are single applications less successful than consortia? I would say yes, but this shouldn't discourage you from applying if you have a very good idea, because the idea is the most important.
So the next one again for you, are there restrictions to reapplying in case of failure?
No, we don't have this kind of punishment like the ERC, so you can reapply both to challengers or to open, or first to open and then to challenges. There are no limits, but please be aware that the conditions for applying, legibility, and the format of the proposal itself are different, and you may rearrange the consortia and rewrite the proposal before you apply.
Thank you. So now the status of the Swiss entities in that call.
Yeah, well, unfortunately, Switzerland is currently considered as third country. So neither a member nor associate country, which means it can be a partner, but it won't be counted as a member or as a associate country, which rules it out for companies in Switzerland to apply as a single member consortia, and even as a two-member consortia, but they can apply as a member of a bigger consortia to challenges. Regarding the financing, they will not get, on principle, they will not get funded by the EU, but there is a program of Swiss government which funds Swiss applicants which are successful in consortia in Horizon Europe. So if your consortia is successful with a Swiss partner, a Swiss partner can still apply for funding from the Swiss government.
Thanks, Dalibor. The next one is for me. So if the research proposes very low TRL, how is a full life cycle or carbon footprint expected to take place? Technological choices to be discovered or made. That's a very good question, and we are working with our experts in how far do we want to go. So we propose that at proposal level, at least you have some numbers in terms of would it be water consumption, energy consumption, whatever you think is your winning factor. Excuse me. And for the full life cycle analysis, we are working on how to do a very simple one, but where we can really go throughout the whole life of the device that you are tackling. But yes, we are going to simplify all this with just the parameters that we think are of interest for the full life cycle analysis. If that answers your question, we are working on that. And as soon as we have for the proposal, I would like to have at least some of the numbers that you anticipate that could happen. Of course, we know that being a TRL one with just one idea, but at least if you can kind of quantify, put some percentages, or at least qualitatively mention that you are not going to use whatever material. So this is e-waste that you are not producing. That can make a deal for the proposal. And then for the if your proposal is selected, we are working on how we want to implement this life cycle. Yes. The next question is also for me. Are only semiconductor applications considered? So now we call semiconductor anything. Semiconductor is a very specific terms for the materials. So the answer would be semiconductor in the wider Semantics, yes, but not only semiconductors. We are talking about electronic devices. So electronic devices can also be a display which can not use a semiconductor material. So yeah, semiconductor in the wider application, yes, electronic devices is the term. So not only semiconductor like a substitution of silicon nitride. We are in the wider scope at this moment. A sensor also could be a device which is not using a semiconductor. Where can we access the EIC portfolios? I'm not sure if I understand the question. If you can fine-tune it a little bit, the EIC portfolios, I'm not sure if they are public. Maybe, Anne-Marie, you know if they are public, the ones that...
I think that I understand the questions. So you would like to see from previous calls for the Pathfinder, which projects are in which portfolio. That's what I believe your question could be. And it's true that we don't have that publicly available yet. We are at the moment developing a tool to which we can do that. And it should be around the summer or so be available publicly. So we started the first portfolios for Pathfinder that were selected from the first work program 2021. These projects have started in September last year. And those projects, of course, they know they are in the portfolio, but we don't have yet a public list of them.
Yeah. The next one also is for me. Should a category of portfolio considerations be targeted in our proposal? So yeah, indeed, you have to fall in at least one of the categories. But as I mentioned during the presentation, you might have more possibilities falling in 2 or even 3 categories, of finding commonalities with other projects, and at the same time finding that we find the diversification. So yes, the answer is you need to fall at least in one of the categories of the portfolio, but of course, like the last one is very open, so I guess anyone can fall in a category. I suggest that you really explain where you think you are falling, and but if you fall in more than one, that could make could be an advantage for you. The next one is, are portfolio managers available to discuss project ideas to ensure that no one area is oversubscribed? Unfortunately, no, we are not allowed to discuss with you the project ideas. And that's why I recommend that you tackle the categories, that you find commonalities, that you really understand where your competition can come from. But no, we are not able to discuss the project ideas. Is the recruitment of a dedicated person for portfolio activities advisable, or should the 10 person months be shared amongst participants? I'm not sure if I am able to answer this one. Maybe Dalibor, you know better than me what would be advisable. I think any of those could work.
Any of those could work. We don't care. I mean, it's your proposal. If you think that one dedicated person with 10 persons months is better, then put it in the proposal. But be aware that 10 persons months is not a huge amount of time for a project which lasts years. So if you share it amongst participants, you will have some persons working very small amount of their work time on the portfolio activities.
Yes, thanks. Is it expected that companies are...
I would like to add to that as well. Of course, there are different activities that you do with the portfolio, and it could, for instance, be that you decide to work with the other projects on a common market analysis. So the persons who are doing that, they should have the knowledge to do that. So you can dedicate it all to one person, but the range of activities is very, very different, and therefore you should really look at what is the content of all those tasks, and then decide who would be best placed to do that. And it can be one person or it can be several persons, but it should be driven by the content.
Is it expected that companies are partners in the consortia? Dalibor, maybe you can answer to this one.
It's not expected. They can be partners in the consortia, but I guess the question is aiming at the evaluation criteria, where in the general horizon evaluation criteria you count the number of SME partners. In the case of TIEs, you should not aim at this in Pathfinder challenges. Portfolio criteria are much more important. That would be my advice to the proposers.
Thanks, Dalibor. In which category would silicon nanoparticles fit in? Indeed, well, it will depend. If you have your silicon nanoparticle per se, which I guess it's not going to be the case, that will be category 2, so inorganic. But I guess maybe you will have a nano composite, so maybe it's category 4, or you will have an ink with it. So, or it depends if you are going to do a hybrid organic inorganic, or are you going to try to do some kind of sort of gel coating at some point? It depends a little bit. But again, even if it falls in 2 categories, that's not a problem. We are really looking for novel activities, for novel ideas, and that's not going to be so important. Finally, the evaluation committee will decide where we want to have those, in which categories, and it could happen that they are in 2 categories, if we see that complementarities with others make sense. Okay. The next one is LCA is not well developed indeed for electronic device fabrication. This will need significant work. What percentage of activity is expected for this part of the work? So this is a difficult one, and I am not going to give a percentage, of course. It will depend very much on the rest of the activities you have to follow. So it depends if you are at TRL very low and still you just have the idea and you have to develop the whole concept of the material, and then you have to go all the way because you have to go to a device and you have also to tackle packaging and durability. Then it might not be a very significant part of the activity, but we really want to check and to see that you are thinking in that way. So you have this life cycle thinking approach. You are really looking at the specific parameters that could make your technology a game changer in this sustainable electronics future. So I'm not going to give a percentage. It will very much depend on the rest of your activities. So electronics equals circuits. Is the focus of the call on circuits and semiconductors as for the CHIP Act, or it includes sensors and all other sort of devices? Sure, I think I answered this one already, but yes, it includes devices, it includes electronics in the wider scope. It is somehow linked to the CHIPS Act, but not directly linked to the CHIPS Act. So, and even in the CHIPS Act, we also have a sensor. So again, electronics and semiconductors in the wider scope that you can imagine. So sensors are very much welcome, yes. And I think they could really, there could be very nice ideas for sensor. Yes, indeed. What about amorphous semiconductors with indium, that is the primary technology for display and more recently for circuits? What if we build it on biosubstrate? This is a tricky one. I would say that it's not enough. I would say that doing something which is already a display on indium, which is, let's say, not breakthrough, and you just put it on a biosubstrate, I would say this is not enough. This is not really what we are looking for. But it will again depend on how you build your idea. And of course, we are pretty much looking for indium-free kind of solutions. So really breakthrough, go for a game changer, no, not for building integration of little things together. If you want to be successful, I mean, that will be the experts that will evaluate your really your excellence and how breakthrough is your idea. But my understanding is that you need to build something really breakthrough. So would planning collaboration with others nominative proposals be welcome in a proposal to anticipate portfolio activities? Dalibor, maybe you can help me with this one. I'm not sure if this is how the experts will evaluate this.
I would say that this concerns mainly the step 2 of panel evaluation, when we search for common parts in the proposals which were chosen in the portfolio. If you plan 2 or more proposals in a way that they have some common parts, this would be taken into account by the panel. But we don't anticipate having a proposal which plans collaboration with other proposals. But we don't we don't prevent somebody to apply in this way. So you can write it in your proposal that you plan to collaborate with another proposal, and list all the shared activities, and it will be taken in account by the panel experts in the step 2 phase.
Thanks. What are the requirements for applications? Can, for instance, solar cells be an application? If you go through I recommend that you go through the topic, and you will see some of the applications that are mentioned there. Of course, it's not mandatory that you go for those. Energy applications are not the ones that we are really aiming for. If you make a very good use case for this, maybe you could have some chances, but really we are looking for applications more in the electronic components side. You can go through the topic and you will see that a little bit. And the last question is, life cycle thinking is very holistic, including environmental, social, and economic. Is this really what you mean? No, mostly environmental part. We are really looking mostly for the environmental part. Of course, social and economic will be a plus in your proposal if you are able to also work on that. But initially, it's environmental life cycle analysis that we will be tackling. Yeah. I think we are done with the questions. Thank you very much. Very interesting, all those questions. Thanks a lot. I think now we can go for the pitches. Is that right, Juliana and
Yes.
Jenny?
So the first company to present is silicon nanoparticles. Jos, this is your turn.
Thank you. My name is Jos Paulussen. I'm associate professor at the University of Twente. And we have developed a strategy to prepare silicon nanoparticles via a wet chemical process. These materials, as you can see here, they're very well characterized: XPS, SEM, Raman, TEM. We can control the crystallinity of these particles, and the process is also scalable. We can easily make 10 grams, and probably we can go for kilograms as well. We ourselves are mostly interested in particles below 200 nanometers in size, but I can imagine a lot of different applications. And to point a little bit out the advantages of this process is that it's much less energy consuming than other techniques. For example, ball milling or pyrolysis. This is a wet chemical process would be much more feasible. If you can go to the next slide. So the silicon nanoparticles offer a set of unique advantages. It's a wet chemical process. Silicon in itself is non-toxic. The synthesis is very scalable, and we can control the crystallinity. And we can also modify this process for other elements. So far, we have not published anything on this. We're trying to protect this IP. And we're currently looking for partners. I could imagine silicon-based batteries. I wrote it here twice by accident, but there should be electronics applications of these particles. You can imagine security labels and also imaging. Silicon is an excellent me-scattering agent, but you can also think, for example, of fluorescence. If you see any applications for these materials, or you see others that I left out, please let me know, and I would be happy to to work with you as in a collaboration. Thank you.
Thank you very much. Next project to present is eco-friendly printed electronics, presented by Gerardo Hernandez Sosa. Gerardo.
Hello. So good day, everyone. So I would like to present myself as a possible collaborator for processing of electronic solution process electronics. My group focused really strongly on inkjet printing. We have clean room facilities. We can go from tabletop to higher stages or larger samples. And we've done, or in my background, we've been working on devices like for light emission, photodetectors, and lately very strongly in, let's say, eco-friendly materials in electronics and how to use, let's say, make functional devices out of these materials. If you can go to the next slide. So here are some examples of our previous work. For example, we've used modified betamin to create an organic light emitting diode. So that would be, for example, for a display application. We've used biodegradable substrates, flexible and stretchable substrates for wearable sensors, from humidity to light, etc. And on the right side, you would see, let's say, what is our capabilities of integrating different type of materials to create a biodegradable electrochromic display. So this display passed a standardized biodegradability test. It is not the final solution of responsible electronics, but it could help you for recovery efforts after most of the material is, most of the device is degraded. We use materials as gelatin, electrolytes, cellulose diacetate as the substrate, and so on. So I would be very happy to hear from any of you if someone needs a group with a good background on electronics, devices, sensors, and additive manufacturing. I'll be happy to hear from you. You can see my email in the bottom of the slide. Thank you.
Thank you very much. Next project to present is Get Greener with Bruno Ricordo. Bruno, the floor is yours.
Do you hear me?
Yes.
Yeah. Okay. We are a company based in France, in Dieppe and Dijon. We're making polyester films, but also other substrates for printed electronics. So our customers are printing circuit boards by screen printing, which is more sustainable than normal PCB, because from etching you go to additive way of manufacturing these circuit boards. So about polyester, so we have lots of advantages to use polyester in the printed electronics because of resistance of mechanical stresses, temperature resistance. But we want to change some things. Polyester films are plastic, and plastics, and then we want to use 70% recycled polyester in our substrate, and it will be something like 50-50 post-consumer and post-industrial. And we want also to decrease the thickness from 25% in the substrate that we use for circuit boards. So this is the first thing what we want to change in the substrate. And we want also to change the way to make the adhesion of a conductive ink on the substrate. And instead of use trichloroacetic acid, we propose to use plasma coating. We have a startup in Dijon, south of France, with a plasma unit where we can do a very thin deposit, some nanometers of coated surface, and it will bring adhesion properties to the polyester, but it can also put adhesion properties on papers, textiles, and so on. And it will be much more recycled afterwards. The energy consumption of this plasma technology is much lower also, only 30-40 kilowatt-hour instead of megawatt-hours if we consider the trichloroacetic technology, and will also reduce sensibly the consumption of ink for the screen printing. So that was the two kinds of developments that we want to do to decrease the environment footprint of screen printing technology of circuit boards. So please, so I am at your disposal of other companies as us, or laboratories, or research institutes to collaborate for new technologies and innovations in this screen printing technologies, screen printing of circuit boards.
Thank you very much, Bruno.
Yeah.
Next
okay.
project to present is Irevchrom with Laura Magini. Laura?
Good morning, my name is Laura and I'm a senior researcher at the University of Vienna. Could you please change slide? Today I would like to introduce you our work on electrochromic materials, especially reversible ones, by introducing first the topic in which this would fit. So if you consider the era of e-commerce and physical disconnect between consumers and brands, there is a problem with counterfeit, which is of course causing a loss in reciprocal trust, increasing the demand of information on product tracking and authenticity. And this need can be addressed by smart RFID NFC labels and antennas, which are able to communicate information on product location and authenticity via specialized apps or readers. However, there are three challenges to address to fully take advantage of this technology. So tampering, sustainability, and offline communication. Materials and electronic components pose a sustainability concern, and as smart labels function by transferring data, an offline secure access should also be granted for direct and trust-building communications with the customers. So in our visions, we want to enable this offline communication by integrating onto smart labels and tickets a printable ultra-low power electrochromic display. However, since mostly ECDs normally operate reversibly, posing false negatives and tampering issues, we made ECDs tamper-proof by developing a new irreversible electrochromic formulation currently not available on the market, which is able to undergo upon activation a chemical transformation switching color from transparent to dark within seconds and that has potentials as low as 1.5 volts. This color change, which can be molded in any shape, text, or logo, will be accessible without instrumentation and last for months without energetic input. This IP has now recently been patented. Please switch to the next slide. To fully exploit our technology, we advanced our initial liquid prototype to a semi-solid one, which can be manufactured in additive manufacturing industrial printed electronics process lines. To maximize the sustainability of our inks, our formulation is now water-based, and our chromogenic material is a natural occurring molecule. We use sugars, salts to modulate viscosity and efficiency, making this formulation completely non-toxic and easily disposable. Because the formulation comprises both the active material and the electrolyte, this formulation is also decreasing the cost and the time of manufacturing. This, of course, is just the beginning of our action, with which we intend to improve the sustainability of printed organic electrochromic displays. Initially, we will, of course, tackle the production of sustainable yet performing materials, but we would like to expand, thanks to partners, our action by tackling also reversible systems before addressing the whole device architecture, including the use of new plastic materials, for example, moving to vitrimers, or the use of new conductive inks for the electrodes to replace indium-based titanium oxide, which we're using now. So please be in contact with me if you need some more information. Thanks.
Thank you very much. Our next project to present is Alma Science Art Paper Ecosystem and Tatiana Costa. Tatiana?
Hello, are you listening?
Yes.
Okay, so good morning. Thank you for the session. So I'm representing Alma Science. We are a sustainable tech and R&D innovation incubator. So we are a collaborative laboratory, and we develop disruptive technologies in IoT and smart packaging, paper electronics, smart cellulose-based materials, and sustainable technologies. So in order to reduce electronic waste and around that. We make the bridge between academia and industry. We were born in the frame of a Portuguese governmental strategy, and in that sense, we have several access to several industrial associates that can help us making the scale up of the technologies that we developed. Next slide, please. And so we basically support innovation and research needs. We do technology development, business development, market research, public relations and marketing, finance, operations. We have facilities and infrastructures. We have a dedicated team of 20 researchers plus an innovation and business development and marketing team. We are involved and are experienced in the participation in European and funded projects. We have now 4 provisional patent applications on the demos and the concepts, proof of concepts that we have developed. And so in this sense, our team is skilled in printed electronics, advanced materials, nanotechnologies, and we have some nice ideas, and we would like to talk to other partners in order to join a consortium, or if somebody wants to discuss some ideas, we can also take in partners to participate in this call. So just please contact us so that we can discuss some ideas. Thank you.
Thank you very much, Tatiana. So these are all projects that presented today. And the stage is back to Isabel and Anne-Marie.
Yes, hello. Hello, here. Am I sharing the slide?
Yes.
Yeah. So yeah, thank you very much for attending. We wanted to finally leave some of the links that we think are interesting for you. So the one for the work program, as Anne-Marie said, this is really the legal basis of the topic. Also, maybe interesting for you is the recording that took place in December for the general EIC Info Day. And we would also want to, oops, let's not go into the next slide. We also wanted to make sure that you can address all your questions to the national contact points, to your national contact points. And I leave here like the QR code just in case you want it. And with that, I wanted to thank you all for attending this session. And also, I would like to thank Dalibor and Anne-Marie for helping me in this presentation. And of course, the backstage, Jenny and Juliana, also thank you very much for helping me in all this presentation. I'm not sure if Anne-Marie, maybe you want to say something else?
No, I also want to say thank you to all the participants, and we hope that this inspired you for many proposals, and that we really get very innovative and disruptive ideas.